How was that? Ah, dzień dobry. There we go. Like I said, I know very few Polish words, so and I won't repeat the ones I do know. So I love this talk. It's a lot of fun, and we still get to learn something during the course of it as well. So I've titled this Common Anti-Patterns. I recently wrote several chapters in a book, 97 Things Every Software Architect Should Know, from O'Reilly. And in there, I wrote about patterns as a communication vehicle for us. But that's only half the story. The other half are anti-patterns. So what I want to do is kind of really look through patterns and what anti-patterns are. And then let's look through about 5 or 6. We'll see how many we can get through in 45 minutes without me talking fast. My goals are to kind of introduce some of the most common patterns, or I should say anti-patterns, that we use every day. Part of it is knowing that the anti-pattern exists. The other piece is understanding, so what? What is the implication of using this anti-pattern? And then finally, the third piece is how to avoid it, just some techniques. I will probably finish right on time. So if you do have a question, I think we have kind of a small enough group. If you do have a question, please, or a comment, something to contribute, please do, because I won't have time at the end for any Q&A. But we do know what patterns are. Patterns are repeatable processes that produce positive results. We have, for instance, the Gang of 4 patterns, which we can use for development. We have architecture patterns by, wow, I did drink a lot. The lights keep going on and off. We have architecture patterns, these ones from Martin Fowler. And also my favorite, integration patterns by Gregor Hope and Bobby Wolf. Lots of patterns. And like I said, we generally use these for communication. If this gentleman and I are working on a project together, and what's your name? Kuba. Oh, a nice, easy name to remember. Kuba. I hesitated when I said, what's your name? I'm like, oh, this is not going to be good. Kuba. So Kuba and I are working on a project together, and he shows me some sketches and says, hey, what do you think? And I look at it and I say, this looks good. Did you think about using the observer pattern? And Kuba says, that's it, and walks away. Did you think about using the observer pattern? That's 8 words. And I have conveyed a whole half-hour or hour's discussion on a type of design. That's why we use patterns. So, if patterns are repeatable processes that produce positive results, then you can probably guess anti-patterns are things that we repeatedly do that produce negative results. The best example I can think of is drinking. If you can remember, it's great during the time. But what happens? I went to college about 25 years ago. But I do remember in the early 80s how the weekends we would spend with vodka parties and 100% grain alcohol called Everclear. It was cheap. And we would drink ourselves silly. We would wake up Sunday morning and say, oh, I will never touch another drop of alcohol again. And of course, guess what happens? The next weekend, we're out buying vodka or Everclear and repeating the same process over and over. Of course, the negative result that comes from this, of course, are our bad livers, not remembering the prior night, all sorts of bad things like that. So it's a great example, but we also have them in technology. We have this occurring all the time in production. We'll be revisiting this code in a little bit. This is an example of an anti-pattern through development. We also have them in design. Now, we'll be revisiting this in a little bit as well. But this is an actual recent diagram from a major U.S. bank. So we'll be talking about that in a little bit. So there are lots of anti-patterns. Unfortunately, there are more anti-patterns than there are patterns. We need to change that. That's one of the reasons for being here. To be able to start recognizing anti-patterns, see that they exist, and try to limit this catalog from thousands of anti-patterns to hopefully just a few that we just can't seem to avoid. Okay. It gets worse than this, though, because there's lots of categories of anti-patterns as well. There's some in economics, testing, methodology, enterprise architecture. We're only going to be focusing just in software architecture and development. I wish we had all day. We can have a lot of fun with economic anti-patterns, couldn't we? At least in the US. So what I'd like to do is take a closer look at these following anti-patterns. I'm not sure if we'll get all the way down to the blob, but we'll try. We'll try. It depends how much discussion we have during each of these. But again, what I would like to do is kind of introduce the anti-pattern, how to recognize the symptoms. How do we know it's occurring? Once we know it's occurring, kind of talk a little bit about, well, what's the big deal? Right? What's the implication? And then finally, the third are just a few ways to kind of avoid these anti-patterns. Okay? So it'll be a very quick tour. So the first one I'd like to talk about is cargo cult programming. This is a fun anti-pattern. This is where you use patterns, frameworks, technologies without really understanding why. Now, this is a real picture and a true story. The word cargo cult comes from World War II. Both the US and Japan had air bases in the South Pacific Islands. And, of course, when the cargo planes came in, it takes a lot of staff, a lot of people to unload these airplanes. Well, the natives would all flock when these planes would come down and help both the US and Japan unload the cargo. Well, this was great because the US didn't need to staff, or Japan, need to staff as many people in these air bases. In exchange, the natives of these islands got food, clothing, medicine, supplies that they otherwise wouldn't have. This is what we call a win-win situation. But of course, we know the war ended, and both the US and Japan both closed down those air bases. The natives, not understanding why, actually built mock airstrips out of bamboo, leaves, timber, whatever material they could find, in hopes of summoning those big birds from the sky. Hence the name cargo cult. So in the 60s, the term was coined cargo cult programming. And it is, in fact, an anti-pattern. My best and favorite example is kind of projects that use the Spring framework, and no one knows why you're using Spring, because it's a company standard, because we were told to use it. Example. But here's very, very simple code. If the year is equal to 2009, the wonderful thing about code, it's kind of universal, isn't it? I don't have to translate that into my bad Polish. The year is 2009, and the month starts with M. Print out true. Otherwise, print out false. What could be easier, right? Let's take a closer look. What happens if it's April 2009? Does this print out true or false? True. How about March 2000? True. How about January 2001? False. It's easy. What if, and notice the top OR bars, what if I use a single OR bar? What happens now? Year's 2009 and the month is April. Is this true or false? It's 2009 and it's April. Would print out true. How about the month being May of 2000? Think. This is an example of cargo cult programming. We are taught to use the double OR bar or the double ampersand for and or. But do we really know what it's doing? what does this do right here when I have the year 2009 and the month is null? What does this produce? A null pointer exception. What does this produce on 2009 with the month of null? True. Yes. The double OR bar short circuits the expression so that if the first part of the expression results to a true statement, it won't execute the rest of it. However, the single OR bar, regardless of the outcome of the first part of the expression, will in fact evaluate the second part of the expression as well. No show of hands, but just ask yourself how many people actually knew that. This is a great example of using a technology, what we call dogma. My karma ran over my dogma, but that's a bad joke, isn't it? I don't know where that one came from. Oh boy. But it's kind of called dogma. This is a great example. Another one is this. Those of you who use Spring, the Spring framework, to do transactions in Spring, we use a transactional annotation here. So we have some code that's placing some sort of order. And we insert update, and what else do? We update some inventory. Will this code work? It does. A majority of the examples that you find on the internet look just like that. And of course the answer is no. It will not work. Does anybody know why? Default, what is the default propagation mode? Is it required or supported? Required. So it will start a transaction. But what's wrong? We're not rolling back on a checked exception, are we? No, we need a rollback for directive on that transactional annotation. I see this often in production code. Yes. Cargo cult programming anti-pattern. I move this here. Some of the ways to avoid this anti-pattern. Responsibility. Something I was trying to learn last night to stop drinking before the session started. Anna had me repeat responsibility. It is responsibility for us as developers as well to understand and know the framework or the technology that we are using. Has anybody here actually read any of the APIs from the Java platform that we use? We use probably in our daily work at least a dozen, maybe close to 15. How many of you have actually downloaded and read the specification for those APIs? Not many, I'm assuming. Why? Well, it's not exciting reading, first of all. And they're several hundred pages long. So it is quite a challenge, but we do need to be responsible. We don't use a framework or a product without at least understand why we're using it. Okay. Here's a technique that I use. When you're reading code or looking through something technical and you come across a word or a method that just doesn't make sense or you don't know what it is, stop right then and there and invest the 10 to 15 seconds it takes to go Google it or look in the Java API. Two things will happen, by the way, when you do this. You'll become a much better developer. Why? Because another aspect of cargo cult programming is repeatedly writing code that is available in the API. How many of you have done the code where you cycle through all the characters in a string looking for a particular pattern? Yes, it's called find all or replace all. Knowing the API will make you a much more productive developer and also increase your skills in that technology. Okay. The other piece kind of related to the specifications. I'm not saying go out and do the specifications, but take time to read about the technology you're using. Okay? But probably most important, we have a term in the US, and it's called RTFM. And this is really what you need to do. Okay. I'm not going to finish that. Now, that's a Polish word somebody will have to teach me before I leave. Okay, so Don't get me started. I'm liable to respond back, and it won't be good. So, okay. So that's cargo cult programming. Another very common anti-pattern that I see all the time is something called the lava flow anti-pattern. The reason it's called lava flow is because obsolete technology or carelessness or people leaving companies and coming into companies tend to leave these hardened globules of code in its wake, kind of like lava from a volcano. Okay, so let's see a very easy example of this. Okay, here's a method. Place order. I would like to place an order. I'm going to insert the order and update the inventory. I then check for overstock discount. This is a discount if we have too many of one size or color of a particular article of clothing. We'll sell it at a discount, 20% off, let's say. And then we calculate the good old tax. And then we process the payment. Well, over time, these were handled by different modules. So the code now looks like this. We don't need to check the overstock discount or calculate the tax in this particular module right here in this method. But guess what happens? Lava flow. This goes into production. How many of you have commented code in production? Yeah, everybody should probably raise their hand. At some point, had commented code in production. What is the implication of lava flow? Well, a couple of things. First, if I change the order object, do I need to go into these methods? Nah, they're commented out. So they're never maintained. Why did you comment those out? Why didn't you delete it? Well, we may need it sometime. No, I'm just not sure. There's no test case for it, but I don't know if they're used. So why don't I comment it out instead? That way, if it is used and I made a mistake, I could just uncomment it, right? But if I delete it, I don't remember what the method name was, right? Yes. So that's one example of lava flow, okay? Here's another example, a real one. This just happened to me recently, within the past couple of years. We have a whole bunch of reports to convert. Let's say we're moving from, Crystal reports to BERT. And we need to rewrite all of our reports. And we have hundreds and hundreds of reports to convert. In actuality, though, these ones that are dark are dead. No one's using them. But you know what the problem is? We don't know that. So if we were to do this properly, we would end up, when we convert this, with just going down from several hundred to maybe 50 reports. But no. Instead, what do? We don't take the time to find out who's using these reports, and we convert them all. And so now we've gone from Crystal reports to BERT, and we still have these hardened globules of dead reports in our wake, like lava flow from a volcano. And the next time we convert, we'll continue to do this forever and ever. So this particular client I was at had a very unique solution to solving this problem. They knew some of these reports were needed for regulatory reasons and for law, but others they weren't sure if they were used. So you know what they did? They turned them off and waited for somebody to complain. A unique solution, true. However, it did work because sure enough, that afternoon we would get several calls. Hey, I don't have my report. Oh, we'll get it right to you. Check that one off. Right? After several weeks, if no one complained, we didn't convert the report. So it's one solution for this. Okay. So this kind of manifests itself in several means. Okay. The best avoidance technique, we all, I hope, use version control, right? Whether it be Git or Subversion or ClearCase or your file system, we all use version control. We should leverage that, because guess what? I can safely delete that code that I commented out. All of a sudden, 3 weeks later, oops, why are those tests failing? Well, because we're not calculating tax. Oops. Well, I can go back in the versions and pull that back. There's no need to comment out code. Okay, so we should leverage version control for what it's used for. Okay. The other one, test-driven development, what we call TDD, with full regression tests and code coverage is a great way of helping to avoid this anti-pattern. The reason, if I have a public method and I have no test case for it, do I need that public method then? It's a great way of finding dead code. Okay? And if I do the research and find I do need it, I write that unit test case. Okay? So it's another technique. Another one is to leverage things like Aviosto or Eclipse that actually can detect dead code in your system. Eclipse does something very interesting. It does detect dead code, by the way. So it won't tell you, it just won't generate the bytecode inside the class file. Okay? But it does at least go part way, so the class files are trimmed down a little bit. Probably the best way, though, is to use interfaces, or what I have here, CDL, which stands for a contract definition language. In Java, we use interfaces for that. You may use WSDL or whichever. If we're using interfaces, it's the same kind of thing as TDD. If I have a public method that has no corresponding interface, is it really needed? Okay? So these are some ways of avoiding this, but it does manifest itself in several ways. Okay. Good. Any questions or comments so far? No? Okay. Just please interrupt me if you do have any. Okay. One of my favorites. The object orgy anti-pattern. Now, I was worried about the translation here, but since the chuckles, I'm sure that most of you know the word orgy. I selected this anti-pattern for a couple of reasons. First, it's probably one of the most common and easiest anti-patterns to talk about. The other is I just love the catalog description. Objects are insufficiently encapsulated, resulting in unrestricted access to their private parts. Wow. Technology is good, isn't it? Yes. Okay. So we saw this code, or some such thing like this, at the beginning when we were talking about anti-patterns. What's wrong with this code? Anything? I see it in production quite often. It's public. Yeah. So this is that E part of encapsulation part of kind of the object-oriented development, kind of polymorphism, encapsulation, inheritance kind of thing. But who cares? What's the big deal? Why is this so bad? Well, there's a couple of reasons. Here, we have a big decimal, which is an object. So if I have a new account, guess what? And I don't initialize it, what is that value? Null. So if I do a get balance, or if I just simply access balance and try to add 10 to it, I can't, because it's already null. So what's the fix? It's very simple. We take the 10 seconds that it takes to right mouse button click, source, generate getters and setters. Wow, that takes such a long time. So what we do is we encapsulate the access to say, hey, for get balance and also for set balance, I can check to see if the balance is null. Because here's the problem. I have 20 other methods that are using this, and I keep getting no pointer exceptions. So in all 20 of those areas of my application, I have try-catch blocks around there. And the craziness continues. So, does this look good? Why? Oh, so if I change these to private, guess what I've done? I've just broken my entire application, haven't I? Yes, which points to the second implication of this very simple but fun anti-pattern, which is I have produced a tightly coupled system. Do you see? Changing those to private just broke everything. That shouldn't happen. I should be able to turn that internal representation from a big decimal to a long. Who cares? Right? I should be able to do anything I want to with my own body. Right? So, yes, those are a couple of the things. The avoidance technique here, really there's two factors that cause us to do this. The first is haste, which is just we're always in a hurry to get stuff done. And so we don't take the 15 seconds to generate getters and setters. Right? Apathy, which is a word that we use just to mean, I really don't care. There's a football game on and I want to watch it. But these are what contribute to this anti-pattern. I will add a third to that, and that's ignorance. Now, not ignorance in being stupid, but unintentional ignorance. Not really knowing what the impact is of not, or I should say, what the impact is of using this anti-pattern. Okay? So, the avoidance technique is simply this. Just don't do it. Right? But at least now, we kind of have a little more thought process about, now I can understand why it's so bad. Right? I mean, we're always taught use encapsulation, but we just saw two examples where we just broke an entire application. Okay. We're okay here, huh? Boy, time goes by fast, doesn't it? Okay. Another one of my favorites, accidental complexity. Okay. This is an anti-pattern that introduces what's called non-essential complexity into a solution. Yes? Close enough. I actually did not hide the bank enough. I did not draw this diagram, by the way. It was handed to me at the client. It is a real diagram. It describes the back-end processing of one of the largest banks in the United States. I have a question for you. Is this complex? No. We can't tell, can we? Because we have made it complex by the diagram such as this. Now, I would say that the back-end settlement processing at a bank is a fairly complex process, all the information flows and stuff. But what we have done by using this anti-pattern is we have introduced unnecessary complexity into something that's already complex. Okay? Some solutions instead of this craziness is maybe do it a little higher level. Right? And then have views to drill down into the spots so I have more black boxes, and then take apart a subsystem and then look at it this way. Why this occurs and why we do it all the time is because we try to fit all the information into one single view, and this results. No one can read it. Okay. Right. What does this do? Mark, it adjusts a number. Very good. Does anybody know what this does? And this is a great example of this anti-pattern. Stop. Guys and girls, this is 2 lines of code. Come on. We're Java developers, right? Okay. A couple of things here. First, the code does work, by the way. Let me ask you this. Does this help any? What does this code do? Look at the title, double if even. So my guess is this code, if x mod 2 equals 0, I double it, which means if the number's even, I double it, otherwise I just return the number. How long did it take me to read that code? Oh, about 5 seconds, right? Guess what? These two do the exact same thing. Cargo cult programming. Who knows the precedence operators? Do you remember what comes first in an evaluation? Let's see what y equals here. Y equals x minus 1. What will I always equal? 1. If it happens to be less than 0 because x is negative, make it a 1. Otherwise, subtract x. Clever. So this means that y is always set to 1. Let's look at this next line of code right here. X mod plus y equals 0. What comes first? What operation actually happens first? That's right, the increment operator. So now, what's y? 2. If x mod 2 equals 0, oh, that looks pretty nasty, doesn't it? Precedence operators, what comes first? The plus, doesn't it? So what's y now? 3. The next operator, division. 3 divided by 3 is what? 1. X times 1 is x times 2 doubles it. And so on and so forth. There's a couple of things that we do. I remember the good old days in C language, what I started programming with way back in the day in the early 80s. We used to have contests, not like the drinking contests you have out here. No, I would lose. So a colleague and I would say, you know what? That's a lot of code. I could do that in 4 lines of code. I could do that in 3 lines of code. I can do it in 2. No, you can't. Yes, I can. And guess what? I did it in 2 lines of code. And guess what? It went into production that way. Yes. A couple of problems that we notice with this anti-pattern. Look at the name, adjust number. That tells us nothing about the method. Now, we don't have to get as bad as Spring framework and exceed the 64-character limit for a method name. However, I have done 2 things in this code right here. First, I have named the method appropriately, so it's easy to read. As a matter of fact, I don't have to look at the code, do I? What's the method do? It doubles the number if it's even. But look how fast it took me to read this code and that code. Okay. So there are 2 things with this. The first is this. Essential complexity. That means that we have a hard problem. Accidental complexity means that we have made a problem hard. And we do it all the time. Now, Mr. Neil Ford was here last year, and he has a great quote. He says this, "Developers are drawn to complexity like moths to a flame, frequently with the same result." Ever been camping and the moths come to the, yes, or outside on the little light? Yes. Okay, so a couple of avoidance techniques for this anti-pattern. The first is avoid the tricky code. We love to do it as developers. It shows us how smart we are, how intelligent we are, how capable we are. Yeah. Is that how you say it? Yeah. Yeah. Yeah, yeah, yeah. I love the way you say yes really fast. Tuck, 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 tuck. I love that. It's great. Yeah, yeah, yeah. I will respect a developer who can write clear and concise code that I could read easily. I will respect that developer more than the one who tries to write really tricky code and show off. Okay? So avoid the tricky code. We know everybody's good here, so we don't need to kind of do that through the code. Look for this everywhere. I've been talking about development, but we saw a design where we made that overly complex. Look for it in architecture, design, and development. Okay? And the best way to avoid this anti-pattern, frequent code reviews. Yeah. Because if I'm reading Kuba's, I'm going to use you because I can easily say your name, Jacob's code, then if I have trouble reading it, it's probably too complex. So it's a great way to gauge, we need to simplify this code. Okay. What are we doing on time? We have a couple of minutes left, right? About 3? Wow. Okay. Well, we will finish with the golden hammer anti-pattern then, which is the most common anti-pattern around. Okay. The golden hammer anti-pattern, this very famous phrase in the US, is using the same tool, the product, the technique to solve every single solitary problem. Okay. We use a screwdriver to hammer in a nail, right? Same kind of thing. I would like to take the opportunity, since this is JDD, Java Developers Day, to pick on Java the language. Right? Java the language is actually quite insignificant. I really don't care much about Java. What I do care about is Java the platform. Did you know that there are over 217 languages that run on the JVM? For example, this morning we coded in Groovy. Runs on the JVM. It's great for XML, short, concise code. It has certain features. The language that runs on the JVM, on the Java platform, called Correlate, which is used for high concurrency type applications. Those that Java is not well suited for. You can kind of see what I'm getting at. XML parsing in Java, ooh. XML parsing in Groovy, easy. Right? Concurrency in Java, ooh. Concurrency in Correlate, great. Scala, one of the up-and-coming languages, at least in the US, I don't know out here, is great for concurrency. It's a functional language, so everything is a function and returns a function. So we're getting back to our wonderful C days when we were able to actually pass, well, we don't pass pointers in Scala, but we can pass functions around. Also great for concurrency, has actors. Cal, how many times have you been in a situation where you've had to mimic or try to write a spreadsheet type application in Java? Yeah. Right. Cal is a specialized DSL language used to mimic Microsoft Excel-like functions. Fantastic. JRuby for any sort of scripting that we can do. Clojure for, again, for great transactional memory. Lisp programmers out there will love this. And how many of you, in the old days, I guess that's just me, right? Boy, do I feel old here. Liked Smalltalk. It's available on the JVM in a language called Bistro. Okay. Here's a link. These are on my website, by the way, so I'll show you the link just in 1 minute. But there is a link, is-research.de/info VM languages. It gives you a list of every language that can be run on the JVM. Over 217. Okay. So some ways to avoid this. Simple. Focus on Java the platform, not Java the language. And the second piece is embrace something Neil Ford terms polyglot programming. It means using the right language for the right purpose. However, something interesting might happen. This Tower of Babel type of anti-pattern, the Tower of Babel, where we have so many languages that don't really talk to one another, no one can figure it out, and we're back to where we started again. Okay. All right. I know I'm frustrated because I love talking about this stuff, and there's about 20 other anti-patterns that I would love to tell you about. However, I'm getting the stop over here. So I will hit this end button over here. And some references. I know you don't have the slides. wmrichards.com/slides, and you can download every one of the slides that I've had today, plus some source code, all that. And there's a whole bunch of links to various anti-patterns catalogs. So again, my goal here was really just to kind of have some fun, learn a little bit, and see this other world that's equally as important as patterns, and those are anti-patterns. So, anyways, dziękuję. Okay.